Right, so we are continuing with this example for the promoter. I will read the question. The promoter of a touring dance show wishes to analyze how the price per ticket affects the size of its audience. She tests two prices, 150 and 200 over 10 shows, each which give rise to the following attendances. So that's a table there. You can see at price 170, the attendances is 150, 110, 125, 120, 120, 105, 115, 115, 125, 115, and 120. Okay. Likewise, the attendances at 200 were those. And then the first question the examiner asked was to calculate the mean and the standard deviation of the attendances for each sample. Now, like I indicated earlier, in this question, you need to input data in the calculator. That's all you need to do, just to input data in the calculator, and then you can pull out the standard deviation and the mean for each sample. So you allow 170 to be X and price 200 to be Y. So when we inputted the data, we were together last time. When we inputted the data, you saw how we pulled out the mean and the standard deviation. I still have them as part of the solution. So the mean was 117. Standard deviation is 6.3246. All these being pulled out from the data that was entered in the calculator. However, my main interest is not to calculate the standard deviation, my main interest is not to calculate the standard deviation and the mean. In this question, my key main interest is to basically perform a statistical test to determine whether the variances of the attendances are equal under the two prices. To perform a statistical test to determine whether the variances of the attendances are equal under the two prices. All right. So when performing a statistical test, we first start by postulating the hypothesis. We start by postulating the hypothesis. So we're going to postulate the hypothesis. By simply saying HO, which is the null hypothesis. Okay. We will say variance 1. I need to put the denotation here. I hope I find the correct symbols. I have seen the symbol. Okay. The symbol is this one for, this is for standard deviation. Okay. Now when you square the standard deviation, it becomes a variance. So this is variance 1. Should equal to variance 2. So standard deviation squared gives us the variance. Variance 1 equals to variance 2 against the alternative hypothesis, which is H1, which should indicate that variance 1 does not equal to variance 2. Does not equal to variance 2. There we have. Then from here, we're going to develop what is known as the decision rule. From here, we are going to develop what is known as the decision rule. And the decision rule always starts with the word reject. So reject the null hypothesis. Null hypothesis is the HO. reject the null hypothesis if f, meaning the f that is going to be calculated, if f will be greater than f at 9,9. I'll explain where the 9,9 is coming from. Let me explain them first. The degree of freedom 1 is n minus 1. And the sample size is 10 for the first set of price. So 10 minus 1, this gives us a 9. Then the degree of freedom 2 is also equal to, beg your pardon, n minus 1, which is also 10 minus 1. Where are these coming from, the 10s? Here, from the question here, the data set, there are 10, starting from 115 up to 120 there. Equally for 200, there are 10, starting from 105 up to 93 there. Okay? So now we are saying, reject the null hypothesis if f, meaning the f that we are going to calculate, at 9,0.025. Okay, there is the 9,9 at 0.025. Now, where is the 0.025 coming from? If you haven't been told at what level you are testing, we assume you are testing at 5%. Now, the test for equivariances, it simply means that the 5% has to be split into 2. By doing that, so we obtain a 0.025. So when we are reading the table, we are going to read the table, the F table. We're going to read the F table at a point where degree of freedom 1 is 9 and degree of freedom 2 is 9, and the percentage is 0.025, which is 2.5. Okay, I said the default is 5%. The question did not indicate at what level of significance are we performing the statistical test. Okay. So now, with this in mind, I can check the table to fish out the reading at 9,9, 0.05. So I did a snapshot of the table. Here is your F table. You'll see it, it's written F critical values here. So this is your F table. And then 9 is here, first degree of freedom. First degree of freedom, okay, is this one, the 9 here, and the second degree of freedom 9 is there. So where 9,9 are meeting, 9,9, let's see if I can use a pencil to just circle something. Okay, so where 9,9 are meeting, this is 9. Where it's meeting 9,9 is at that value, 4.03. 4.03. So my degree of freedom is my critical value is 4.03. So sorry about that. I might still need this, but this time around the eraser maybe just get rid of that line. Okay, 4.03. So the 4.03, I've put it there. And then now we can make a comparison with what we're going to calculate. So we are saying F, this F which I'm saying here, if F is greater than, the F I'm talking about is the F which we are going to calculate, okay? And we had pre-calculated the F. The F value is variance 1 divided by variance 2. So if you see, we had calculated the standard deviation area. The standard deviation for 1 is 6.3246. So when you square this standard deviation, the 3.426, when you square it becomes the variance. So that's what comes on top there, variance 1 squared, okay, variance 1. And then below there, the standard deviation for Y. And the standard deviation for Y is 5.2757. When we square it, it becomes a variance. Okay, so there it is, 5.2757 squared. After computing 6.3246 against 5.2757 squared, we are finding 1.44. Dividing 6.3246 squared divided by 5.2757 squared gives us 144. Okay, now we can make a comparison. Is our F, which we have calculated, which is being mentioned here, is our F, this one, greater than the F 4.03? So the calculated F is this one, which we are talking about as F, should be greater than this F at the address of 9,9, 0.025, which is 4.03. So is it greater? The answer is no, because the F calculated is 1.44. So it's not greater than 4.03. Therefore, should we reject? The rule is to reject the null hypothesis if the F is greater, but the F is not greater. So we are not going to reject. We will accept the hypothesis. But what we are going to say, there is a language which should be used where we don't go directly to say we've accepted the hypothesis. We will say we fail to reject the null hypothesis since the F we calculated is less than. Since the F we calculated is less than F, which is from the table 4.03 at the address 9,9,0.025, which is 2.5. I said we are testing at 5% because we're not told at which level to test, but we take the default 5% and then we divide it by 2 because the testing for equivariances is a two-sided test. That's just the rule. We are testing for equivariances and the testing for equivariances is a two-sided test. So we'll have that now, 4.03 being recorded there. And then from here now, we can conclude and say, we thus have evidence, we thus have sufficient evidence, language there. We thus have sufficient evidence to conclude that. So what are we concluding? Are we rejecting the null hypothesis, the HO? No, we are accepting it. What is the HO saying? It is saying variance 1 is equal to variance 2. So we've accepted that statement. So when we're making a conclusion, we are going to conclude to say variance 1 is equal to variance 2. We thus have sufficient evidence to conclude that the variances under the two prices, are equal. Because that's what the statement is saying. We fail to reject the null hypothesis. So the null hypothesis is saying variance 1 should equal to variance 2. That's how we test for equal variances. Thank you very much for catching me in this tutorial. Join me in another tutorial where I'll be explaining the t-test when the variances are equal under the two systems.